Hello and welcome back for another VMK in the C++ series. In this VMK, I'll be discussing class inheritance. Let's go right into Visual Studio and create a new project. It's going to be a Win32 console project, and we'll call this guy inheritance. Under application settings here, you should have console application selected. And here's our main entry point for our program. In the previous VMK, I showed you how to create a class, so I'm not going to dwell too much upon that. What we want to focus in this VMK is how to inherit from a base class to create another class. So what I've done here is I've created a vehicle class, and in the constructor we're going to print vehicle and parentheses so that we know that we're initializing the constructor. We have one member variable defined down here in the public section, and it's called m_i number of wheels, and we'll define the number of wheels for this vehicle to be 4. We also have a virtual destructor. Inside of the destructor we have this printf command, which will print to the screen that we are finished with the class and it's being destructed. Now inside of our main body we're going to create one of these vehicles, so we'll type vehicle, and then we need to give this item a variable name. So I'll just call it, I don't know, unknown. And in here we can go ahead and do the standard stuff where we can save different values for the number of wheels. Let's say we upgrade this vehicle to have 6 wheels, like so. And then our program is going to quit. So let's compile this guy and give him a run and see what happens. As expected, we go in, call the constructor, and then once we're done with it, we're going to call the destructor. We don't print the number of wheels to the screen, so that doesn't get shown in the output. However, we did change it from 4 to 6. Okay, now let's start working with inheritance. Up till now, I've only been working with the standard class. But what we can do is we can take this class and make it our base class that we inherit from whenever we create classes. Let me show you how this works. What I've done here is I've created a class called car, and I have a full colon and then the word vehicle. Vehicle is the name of our base class, so this tells me that car is inheriting for vehicle. Inside of the constructor, I'm going to print car, and I also have a virtual destructor where I also print to the screen showing that the destructor is being called. There are no public or private members, so everything here is blank. I can compile this code, and you'll see that it compiles fine. And now let me show you how we can use this inherited car class. We define a variable the same way we do as always. So this time our class is called car, so I'm labeling car here. And we're going to name this variable maybe Volvo. Now because Volvo is from car and car inherits from vehicle, the Volvo takes on all the properties that vehicle has. And we can see that by just going like this. You can see that I have access to the number of wheels, which is part of the car. But if you notice in here, the class car does not have any member variables. The reason why we have these number of wheels accessing to us is because we've inherited from car. So everything inside of this class we have access to. And if I were to compile this, oh, I made a mistake here. Oh, because I've accessed the number of wheels, but I actually didn't use it. So, for instance, I could do something like this. Now my number of wheels for the Volvo is going to be set to 2. Let's take a look here. Oh, right. The way we've defined this is that vehicle cannot access car using private to inherit from vehicle. What this means is up here the number of wheels is public to this class. However, when we've inherited here, we've inherited vehicle to be a private class rather than a public one. If we want to inherit publicly, we would just type in the keyword public, and as soon as we compile now, everything is fine. So this keyword here was missing, and by default the compiler assumes it's going to be private. So we're going to be inheriting privately, which means everything in here that we have defined is going to be private to our car. But if we define it as public, like so, then whatever we have here is the same structure we're going to have down here inside of the car class. So anyway, going on, we've compiled the program. Now let's just run it to take a look at what happens. We created our vehicle, and then we created a second vehicle, then we created a car, and then we destroyed the car, the vehicle, and the second vehicle. Now let me just get rid of one of these vehicles to clear up what's going on here. So we're only going to be working with this Volvo. And as soon as we create this Volvo, notice what happens. We actually create a vehicle first, and then we create the car. So in other words, the vehicle constructor gets called first because the car inherits from vehicle. Then our car constructor gets called, and then when we exit out of our program, our car destructor gets called first, and then our vehicle destructor gets called second. The order of this is very important because sometimes when you're initializing variables, you want to make sure that you're initializing them in the correct order. So for instance, I've specified here to initialize the number of wheels inside of the vehicle constructor. However, I can also initialize this same variable inside of the car constructor like so. And let's say I change the number to 2. Well, if I do this, and then let's just go into here and set up a breakpoint, notice what happens. Volvo is created, so we can go in here, type in Volvo to take a look at our variables, and notice that the number of wheels is set to 2. So this constructor got constructed first, set the variable to 4, however right afterwards we went into this constructor and overwritten the 4 with a 2. So if we really wanted to have 4, we need to make sure that the number of wheels gets constructed here to be 4 rather than up here to be 4, because the order of this construction is going to be very important. So that's basically how you use inheritance and variables within them. You can pass variables from one class to another, or actually I should say you can access variables from an inherited class. However, you have to be careful on how you define the inheritance, whether it's public or private. Now there's one other thing I wanted to discuss here. You'll remember that we can define variables as being public or as being private. And if we define them as public, then we can do things like this. Where we can change the value of our variables from outside of the class. And right now, this compiles perfectly fine. However, you've seen that we cannot do that if we were to take this variable and move it into the private section. If we try to compile this, then the compiler gives us an error message saying that cannot access private member declared in class vehicle. Okay, well, now let's take a look at this. If we have our member variable here defined as private, well actually, first let me move this back. If I have this member variable defined as public, and we want to take that variable and assign it to some value inside of our car class, which inherits from vehicle, we can do that. Everything's perfectly fine, and you've already seen this because I've built it and it succeeds. Let me get rid of this. Now if I take this variable and move it into the private section and try to recompile, notice that I get an error message. It's the same error message that we had before, where it says that the number of wheels cannot access private member declared in the vehicle class. Because this is private, I do not have access to that variable down here outside of the class, and I also do not have access to it from a class that's inherited from the base class. However, there is a way to get around this. We can make it private so that we cannot access it through here, but we can make it accessible to any class that we inherit from the base class. And the way we do that is we create a new section and we call it protected. If we define a variable as being protected, and you can do this with functions as well, the protected ones are going to act in the similar way that private ones do. So notice that if I were to uncomment this line of code down here, and let me just comment this one out, what I'm trying to do now is access the number of wheels of the Volvo outside of any class. And if I try to compile this, I still get that same error message saying that cannot access protected member declared in class vehicle. However, because this variable now is protected rather than private, I can do this. This is perfectly legal. And I can show you that just by compiling, and notice it succeeds. So by protecting a variable, what you're really doing is you're making it private to anything outside of your class, but you're making it public to anything that inherits from the base class. So we have public, private, and protected. Those are the three different categories you can group functions and variables under inside of a class. Now, when we inherit variables inside of these classes, the inheritance happens only in one direction. Let me show you what I mean here. This vehicle that we've created has the variable I number of wheels. And we can see that just by hitting the period sign after the name of the variable. And Volvo, which inherits from vehicle, also has that same member variable because we've inherited from car. Let me just fix this over here. We have that same variable that we can access. Now, we can create variables that are part of the car, but as soon as we do that, they will no longer be part of the vehicle. So the vehicle, which is the base class, has no knowledge of the car. However, the car does have knowledge of the vehicle. This is what I mean by it's a one-directional relationship. I'm going to take this, just put it back over here, and I'll create a public member here, maybe a Boolean, and it's going to be called broken. So for instance, this car can be broken or not, so it's a Boolean variable. And now look what happens over here. The unknown vehicle just has the number of wheels we can access. However, the Volvo has broken and a number of wheels. Both of these variables are now accessible to the car. And the reason for that, again, is because car has the public variable, which is declared for himself, but he also inherits the variable that comes from the vehicle class. Okay, I think there's only one other topic I wanted to discuss inside of this inheritance lesson, and that is virtual functions. Inside of the base class, we can create a virtual function which will force us to include the same named function inside all of our classes that we inherit from. Let me show you how this works. We're going to create a virtual function, and it's not going to return anything, so I'm just going to have void here. And I'll call this function update. I'm going to create it to be purely virtual, so I make it equal to 0 like so. As soon as we declare this virtual function, notice what happens down here. Let me just comment this out. If I try to compile our code now, you'll see that it does not compile, and our error message says vehicle cannot instantiate abstract class. Because we have this virtual function right here, and it's purely virtual, this means that this class actually is not defined for us. This function needs to exist, but because it's purely virtual, it's equal to 0, it hasn't been defined. So that means we can no longer use vehicle by itself. However, we can still use car, and I can demonstrate that just by commenting this out. It's giving us a problem now because car cannot instantiate an abstract class. And what this means is car needs to declare this update function before we can actually use the car class. So if we go in here and define some sort of function, update, let's say, I don't know, we're going to take our broken variable and change it to be false. Now if we compile the code, it perfectly works fine because we have defined update within our car class, and it knows that vehicle doesn't need to have update, but vehicle is forcing car to have an update function. So that's how you'd use virtual functions. When you are using virtual functions, you don't need to make them purely virtual. You can do this. This is fine. For instance, let's create some sort of update here. I don't know. Let's create another variable to play with. And let's say that When we call update here, our speed is going to be equal to 10. And when we have, well, actually, let me show you what this does. So what I've done is I've created a virtual function inside of our vehicle class. And when I compile my code, this time it's perfectly fine. Notice that because it's not purely virtual, it doesn't matter that my car class doesn't have an update function defined for us. And as a matter of fact, let me do this. Notice that if I compile it now, again, it still compiles perfectly fine, and we are allowed to define a vehicle even though we have this virtual function declared up here. What I'm going to do is, over here, do a printf function. And we'll do the same thing over here in a minute. I actually want to display the output to the screen, so what we're going to do here is call unknown and then update. When we run the program, you notice that we have constructor, speed is set to 10, and then we have our destructor. I forgot to add a carriage return to the end here. So there we go. Constructor, speed of 10, destructor. Now, let's see what happens when we declare this guy. If we run the code again, we get the same behavior. Constructor, speed is 10, destructor. If we create a car, which I've named here Volvo, and I call update on him, notice which update gets called. We call vehicle, which is the constructor. Oh, actually, let me remove this guy to make it clearer. We call vehicles constructor, the car constructor, and then the update of the car because the speed is set to 5. Then we have the destructor of the car and the destructor of the vehicle. So we have both an update here inside of the car, and we also have an update inside of the vehicle. And we are currently only displaying the update that gets called here from within the car when we're using the car class over here. However, because this guy is virtual, what we can do is we can force ourselves to call the update within our inherited class. The way we can do that is by calling vehicle, we do double colon sign, and then we say we want to call the update function. What this is going to do is every time we call the car's update, we're going to force ourselves to call the vehicle's update first, and then we're going to go and do whatever we have down here. So let's compile our code and give it a run. And notice now what happens. We have vehicle constructor, car constructor. We call speed equals 10, which is straight from our vehicle's update. And then we have displayed to the screen speed equals 5, which is the update being called from within the car class. So you can play around with the way that everything is being handled as soon as you have inherited classes. And things can get very hairy very easily because you can continually inherit from one class to another to another to another. So you have to be careful when you're using inheritance. However, inheritance is very powerful. You can build up very simple classes as your base and then continually add to them to give more and more complexity to whatever you're trying to create. And that's where the real power of object-oriented programming comes from. Alright, I think that's it for now. Play around with inheritance, get familiar with it. It's a very powerful technique. And come back for the next VMK where I'll be talking about the copy constructor.